Hello, myself Veena, Assistant Professor, Department of Mathematics, Government Science College, Bangalore. In this session, in line and multiple integral chapter, let us study about computation of volume by triple integrals. So, prerequisites for this session is one must know about definition of triple integrals, concept of triple integration, and the relation between Cartesian and spherical polar coordinates. So these are the formulas we use to find out triple integral in different coordinates type. In Cartesian coordinates, we find out the volume of the region R using formula triple integral of dx dy dz over R, that is equal to integration from a to b dx, integration of g of x to h of x dy, and integration of pi of xy into theta of xy dz. It is in Cartesian coordinates. In terms of cylindrical polar coordinates, V is given by triple integration of r dr d pi dz over capital R. In terms of spherical polar coordinates, volume V is given by triple integration of r square sine theta dr d theta d pi over R. These are the formulas used to find out volume of a region. Let us take one example. Find the volume common to the cylinders x square plus y square is equal to a square and x square plus z square is equal to a square. So, here in the given region, z varies from minus of square root a square minus x square to plus square root a square minus x square, and y varies from same minus of square root a square minus x square to plus square root a square minus x square. For z is equal to 0 and y is equal to 0, x varies from minus a to plus a. So these are the limits of x, y and z. Therefore, v is equal to, by using the Cartesian coordinates, x is varies from minus a to plus a, y varies from minus of square root a square minus x square to plus square root a square minus x square. Integration from z is equal to minus square root a square minus x square to plus square root a square minus x square dz dy dx. Now first integrate with respect to z. So integration of dz is z and the limits are minus square root a square minus x square to plus square root a square minus x square. Since lower limit having minus sign, so by putting these values for z, we will get 2 times square root a square minus x square dy dx. Now again integrate with respect to dy. So integration of this is nothing but with respect to dy is, now 2 is a constant take outside. So integration of dy is y. So it is equal to square root a square minus x square into y. Again put the limits for y, that is upper and lower limits. Since lower limit having minus sign, again after putting the lower and upper limits, we will get 2 times square root a square minus x square. So 2 is a constant take outside, it becomes 4, and square root of a square minus x square into square root of a square minus x square becomes a square minus x square. Now integrate with respect to x, we will get a square x minus integration of x square is x cube by 3 and x varies from minus a to a. Now put the lower and upper limit, it becomes 4 into 2a cube minus 2a cube by 3, and after simplification we will get 16a cube by 3. This is the volume of a region by using Cartesian coordinates. Second example. Find the volume bounded by the cylinder x square plus y square is equal to 4 and the planes y plus z is equal to 3 and the z is equal to 0. Z coordinate is 0. That means here z varies from z is equal to 0 to z is equal to 3 minus y by using these two. Now y varies from, by using this, y varies from minus square root of 4 minus x square to plus square root of 4 minus x square. And to take y is equal to 0, we will get x varies from plus minus 2 to plus 2. So these are the x, y and z limits. Therefore, required volume is given by V is equal to x varies from minus 2 to plus 2, y varies from minus of square root 4 minus x square to plus square root 4 minus x square, and z varies from 0 to 3 minus y dz dy dx. Again, integration of dz is equal to z, so it varies from 0 to 3 minus y of dy dx. Now putting the limits, we will get 3 minus y. Again, integrate 3 minus y with respect to y, we will get 3y minus y square by 2. Again, putting the limits of y, that is plus square root 4 minus x square in the upper limit and minus square root of 4 minus x square in the lower limit. So we will get 3 of square root 4 minus x square minus 4 minus x square by 2. This is the upper limit, plus 3 into square root 4 minus x square plus 4 minus x square by 2 in the lower limit. So after simplification, we will get 6 into integration from minus 2 to 2 square root of 4 minus x square dx. It is a standard form, that is integration of a square minus x square root of a square minus x square, that is equal to x into square root of a square minus x square by 2 minus a square by 2 sine inverse x by 2. So therefore, putting this standard formula of integration, we will get this equation. Again, by putting lower and upper limits 2 and minus 2. So 6 into 2 into sine inverse 2 by 2, because it is 2, 4 minus 4 is 0. If you put upper and lower limit, it becomes 0. First limits become first part is 0. In second part, if you put low upper limit, it is equal to sine inverse 2 by 2 sine inverse 1, that is minus 2 sine inverse 1. And if you put lower limit, it is equal to minus of minus becomes plus 2 sine inverse minus 1. So therefore it is equal to 6 into 2 times sine inverse 2 by 2 minus 2 into sine inverse minus 2 by 2, or that is equal to sine inverse of 1 is pi by 2 and sine inverse of minus 1 is minus pi by 2, that is minus becomes plus. So 12 into pi by 2 plus pi by 2, that is equal to 12 pi. This is the volume of a region by triple integrals. These are the references I used. Thank you.